A stand is being used to prop up a portable solar panel. It consists of a support that is hinged to the panel near the top and an adjustable strap joining the panel to the support near the bottom. By adjusting the length of the strap, the angle between the panel and the ground can be changed. The dimensions are as follows. The distance between A and B is 30 centimeters. The distance between A and D is equal to the distance between C and B, which is 5 centimeters. The distance between C and F is 22 centimeters. The distance between E and F is 4 centimeters. We want to find out how long the strap has to be in order to make the angle alpha between the panel and the ground equal to 60 degrees. So we can lengthen the distance between D and E, or shorten the distance between D and E, by moving the strap in and out through a hole here at point E in the support. Two diagrams are given below, one showing triangle CAF, and the other showing triangle CDE. Use the measurements given above to record on the two diagrams below the lengths of two of the sides in each triangle. Well, CF, as we can see here, is 22 centimeters. Now, we can't get AF. We don't know what that is so far. What about AC? That's the distance from this point A to this point C. How do we find that? Well, we know the distance from A to D is 5. What is the distance of D to C? Well, we get that by going to this diagram here. The distance of A to B is 30. And if we take 5 and 5 from 30, we'll get the distance between D and C. Well, 30 minus 10 is 20, so this distance here is 20. Actually, I forgot to add on the 5. We want the distance of C to A is 20 plus 5. 20 plus 5 is 25. Now let's look at CDE. Well, we know the distance of C to D now. It's 20. What about the distance of C to E? That's the distance of here to here. Well, the distance of C to F is 22. The distance of E to F is 4. 22 minus 4 is 18. So CE is 18. So that's what we had to do. Mark two distances on each of these triangles. Triangle CAF and triangle CDE. Taking alpha equals 60 degrees as shown, use the triangle CAF to find angle CFA, correct to one decimal place. Angle CFA is this angle here. CF is one arm, FA is the other arm. F is at the vertex of the angle. I'm going to call this angle that we're going to find angle A. Forget the corner of this triangle, it's also called A. But I just want to use the sine rule here. So we use the letter A to represent the quantity that we're looking for. In this case we're looking for an angle, so we have to use capital A. If this is capital A, then the side corresponding to it is small a, which we have. Small a is 25. Now we need another side and a corresponding angle. We call that other side B, small b for a side, and capital B is the angle that's opposite small b. So you see now we have enough information to use the sine rule. So here is the sine rule. We're looking for angle A. It might be easier to turn both sides of this upside down in order to enable us to isolate sine of A. So we have sine of capital A divided by little a equals sine of capital B divided by little b. So we just invert both of these fractions, and this is still true. Now we're interested in capital A, so we multiply both sides by little a. So we have sine A equals little a times sine B over B. So I multiplied the left hand side by little a to get rid of the a. So we're left with sine A on the left hand side, but I must multiply the right hand side by little a as well. So now we can fill the values into this to find out what sine A is. Little a is 25 times sine of capital B, which is 60 degrees, divided by little b, which is 22. So we have the sine of 60 multiplied by 25, and then we have to divide this result by 22. So I will write this down to about 5 decimal places, 0.98412. So that's the sine of angle A. We're interested in angle A, so we have to get the inverse sine of this number. So I leave in the full form. Well, it's not the full form, it goes on forever actually, but I'll just get the inverse sine of the quantity here. So here is the angle that we're looking for, the angle that I called A for the purposes of the sine rule. To 1 decimal place it is 79.8. Hence find angle ACF correct to 1 decimal place. Well, ACF is this angle up here. One arm is AC, the other arm is CF. The letter C in the middle here is at the vertex or corner of the angle. Well, we have two of these angles. The three of them add up to 180 degrees because we have the three angles in a triangle. So it's easy to find angle ACF. Subtracting, we get 40.2. Use triangle CDE to find the distance between D and E, which is the length of the strap, correct to 1 decimal place. Well, we can see that CDE is part of triangle CAF. Actually, this point here is D, and this point here is E. So this angle here is the same as this angle here. And we've worked out this angle, so now we know this angle. DE is the strap. So here's the situation. We want to find DE, that's the side opposite this angle, which we know to be 40.2 degrees from the previous part. So we're looking for a side, so when we're looking for something, we call it A. If it's a side, we call it small a. This side is small a, then the angle opposite the side is capital A. So whether we're using the sine rule or the cosine rule, it's a good idea to use this convention. Okay, so A is what's missing, what we're looking for. Capital A we have, it's 40.2 degrees. Now, small b and small c are the other two sides. We have the other two sides. We can call one of them B and the other one C. It doesn't matter. Let's call this one B. And let's call this one C. Capital B and capital C are the angles opposite these sides. Capital B is this angle here, which we don't know actually. Capital C is this angle here. So this is capital B and this is capital C. We don't know either of these two angles, so we can't use the sine rule. So here's a situation where we use the cosine rule. If we have two sides and an angle in between the two sides, and we're looking for the third side or one of the other two angles. Well, actually, if we just have two sides and the angle in between, we're using the cosine rule. So we have small b, small c, and capital A. We don't know what little a is. We don't have enough information to use the sine rule because we don't know capital B and we don't know capital C. So here is the cosine rule. Now this is the only form you need to know. There are other forms which you can ignore. If you label your triangle correctly, then you only need to use this form. Little a is the side you're looking for. Capital A is the angle that's opposite little a. And these are opposite each other in the formula. So let's just plug in the values. So we have a squared equals b squared, that's 20 squared, plus c is 18 squared, minus 2 times 20 times 18 times the cos of 40.2 degrees. Here is what I get for a squared. You plug all this in. Now we want a, so we want the square root of this number. So rather than clearing the calculator, I'll just put this number to the power of 0.5. So you don't have to be doing any rounding or re-entering the value. So we get 13.19. We want this correct to 1 decimal place. To 1 decimal place, this number is 13.2. All the dimensions are in centimeters, so our answer is 13.2 centimeters. So the distance of D to E, or the length of the strap, has to be 13.2 centimeters if we want this angle here to be 60 degrees.